Welcome to our next lesson in triangles. So first we will start with SSS congruence rule. What is this? Triple S indicates side, side, side. So if three sides of one triangle are equal to the other three sides of another triangle, then the two triangles are congruent. If three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. Okay, now we will see the next theorem. What is it? It is called RHS congruence rule. If in two right angles the hypotenuse, triangle rather, the hypotenuse on one side of one triangle are equal to the hypotenuse and one side of other triangle, then the two triangles are congruent. If into right angle triangle rather, right triangle, triangle, this is triangle, it is n. Okay, so what exactly it says? So we will draw two right angle triangle. What the theorem says, if hypotenuse is equal to hypotenuse, let us say it's right angle, so another side is equal, then the two triangles are congruent. If in a right angle triangle the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of other triangle, then the two triangles are congruent. Okay, let us mark ABC. If you know AC and AB, can you find out BC? BC is equal to root of AC square minus AB square is equal to root of, suppose in this other triangle, if we make DAF, DF square minus DE square, PC or EF, both are equal. Because AC is equal to DF, AB is equal to DE, given hypotenuse on one side. So then we can find out the other side. So this is RHS congruence rule. R stands for right angle, hypotenuse on one side. If the two triangles are in the two triangles, if they are equal, then the two triangles are congruent. So if their two triangles are congruent, then angle A is equal to angle D. Angle C is equal to angle F. Of course, the other angle is right angle. It is given. So we'll just see the next problem. ABC is right angled triangle in which A is 90. So it is given AB is equal to AC. Find the angle B and C. ABC is a right angle triangle in which angle A is 90. Find this is an isosceles triangle. So AB is equal to AC. Therefore, angle B is equal to angle C is equal to 45 degree. How? This is one angle is A, other two angles, angle B plus C is equal to 90. Therefore, angle B is equal to T is equal to 45 divided by 2. So we'll move to next problem. In triangle ABC and DBC are two isosceles triangles on the same base BC, and vertices A and B are on the same side. So we have now drawn the diagram ABC, and so what are the points first given, and DBC or isosceles triangle on the same base BD. Base is BC. So what is given? AB is equal to AC and DB is equal to DC. This isosceles triangle given. So if AD is extended to intersect BC at P, so we have made the construction two triangles with the same base ABC and DBC are two triangles, isosceles triangles. So we are construction is join AD and extend it to P meets base BC at P. So we will mark now what is the meaning. First line AB is equal to AC, isosceles triangle. So AB is equal to AC. Next BD is equal to DC. So what show that triangle ABD and triangle ACD is equal to. So it's very simple. These two triangles, AD is common to both the triangles. So the first proportion of it, triangle ABD is congruent to triangle ACD. All the sides are equal to one another. So all sides are equal. What are sides equal? AD is common. AB is equal to AC and BD is equal to BC because it is isosceles triangle. So these two triangles are congruent. What is next one? What about triangle ABP and triangle ACP? Now when the first part is proved, what is that? Angle BAD BAD is equal to angle CAD. So these two angles marked there equal. So this we used to the next use improving the next problem. What next problem says? Triangle ABP and triangle ACP. So we are considering these two triangles. We know AB is equal to AC given it is isosceles triangle. And in these two triangles AP is common to both the triangles. And what about angle BAP? Angle BAD or even BAP is same. BAP is equal to angle CAP. Now we will apply SAS congruent rule. So by SAS congruent rule, triangle ABP is congruent to triangle CAP. So we'll move to next problem, next part of the problem. So it says AP bisects angle A, that we have proved. AC, what is this? AC, AP bisects angle A. Those two angles are equal, we have to prove. BAD is equal to CAD, we have to prove. Because these two triangles are congruent, therefore these two angles are equal. So you see the same order, BAD, CAD, these two angles are equal. So third question is by 1 ABD triangle ABD is congruent to ACD. Therefore, angle BAD is equal to angle CAD. Therefore, AP bisects angle A as well as angle D. How would it be? Okay, now we'll see the triangle 2 we have proved APP is congruent to ACP. We will minus this small triangle, then we will get APD and CPD are congruent. Therefore, these two angles are equal. So we will mark one like this. So triangle ABP minus ABD triangle, okay, everywhere, is equal to triangle BPD triangle ACP minus triangle CAD is equal to triangle CPD. So by 1 and 2 we have proved ABPs, these two are equal, these two are equal. So therefore these two are equal. A 1 and 2 triangle BPD is congruent to triangle CPD. Therefore, angle D also equal BDP is equal to angle CD. Fourth question, AP is perpendicular bisector of BC. Bisector we have proved it is isosceles, therefore it is perpendicular bisector. How we can prove? So the fourth portion we can prove this way also. AB is equal to AC isosceles triangle. Angle A is bisected. Angle B is equal to angle C. And angle BAD is equal to angle CAD. Approved above. So what about the third angle? These two angles are equal. So if two angles of a triangle, our third angle is APB is equal to APC is equal to 180 divided by 2 is equal to 90 degrees. How it is 180? So APB plus APC is equal to totally was 180. These two angles are equal. Half of it is 90. So we'll move to next problem. AD is an altitude of an isosceles triangle ABC in which AB is equal to AC. So in all these problems, first we will draw the diagram that will help us to understand the problem clearly. So vertex is A, AB is equal to AC. So these two are equal. AB is equal to AC. Show that AD. What is that AD? Bisects BC. Yes. What is that AD? AD is an altitude of an. This is altitude means it is perpendicular. Show that AD bisects BC and AD bisects angle A. AD is an altitude. So it is isosceles triangle means these two angles are equal. So ABC is isosceles triangle. Angle B is equal to angle C. And we know angle ADC is equal to angle ADB is equal to 90 degrees. Therefore, what about the third angle? Therefore, angle DAB is equal to 180 minus ADB minus angle B. DAB. What about DAC? DAC is equal to 180 minus ADC minus angle C. So see, these B and C are equal. ADB is equal to AD 90. Therefore, angle DAB is equal to angle DAC. And AD bisects the angle A. So it is an isosceles triangle. The next part of it is very easy. See, the second part of it we can prove this way also. AB is equal to AC. Angle B is equal to angle C. Angle BAD is equal to angle CAD. Therefore, by ASA congruent rule, so triangle ABD is congruent to triangle ACD. So therefore, BD is equal to CD. So next problem, two sides of AB and BC. So AB and BC and median AM of triangle ABC. So AM is median, means these two BM is equal to MC. Then only it's median. Median means the opposite side is divided into equal portion. PN equal to sides PQ and QR and median PN of triangle PQR, another triangle. Show the triangle ABM and PQN are congruent. Two sides of one triangle AB and BC are equal and median. So what is given? We'll mark AB is equal to PQ. BC or QR. When BC, so it's like that. BC is equal to QR. So half of BC is equal to half of QR. Half of BC is BM. Therefore, BM is equal to QN. So this BM is equal to QN. So what is this? Triangle ABM and PQN are congruent. First, he asked us to prove. So how we can go about in this problem? And to see in the what is given, median AM is equal to median PN. So the third point is AM is equal to PN given. It is median. So in these two triangles ABM and PQN, all the three sides are equal. Therefore, by SSS congruent rule, so they are congruent. Three sides of one triangle are equal to three sides of the other triangle, and the two triangles are congruent. So with this we have come to end of the second chapter. What is it? So we'll briefly say we are have dealt with the SSS congruence. So if three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. Next, RHS rule. If in a right angle triangle, if the hypotenuse on one side of one triangle are equal to the hypotenuse on one side of the other triangle, then the two triangles are congruent. So these two are the main matters. Thank you for listening patiently. Please go through the problems again, and thank you.